Okay, good morning everybody. How are you? Today we'll start our series of lectures in trigonometry. Trigonometry simply is how to measure lengths or how to find the length of a straight line and the size of any angle. Before we start putting the rules, we have to know something. We have 3 chapters that covers trigonometry. Chapter 5, Chapter 6, Chapter 7. In Chapter 5, it talks about only right angle triangle rules. While in Chapter 6, we talk about non-right angle triangle rules. When we say none, it means the triangle could be acute angle triangle or could be an obtuse angle triangle. These will deal with them in Chapter 6. And when we go to Chapter 7, we'll talk about trigonometric functions, how the function look like. Remember how the linear function looks straight line? Remember the quadratic function? How does it look like? A parabola? Well, the trigonometric function looks a little different. So today we will start with rules related to right angle triangles. What's a right angle triangle? It has 6 elements. It has 3 sides, 3 edges, and it has 3 angles. I can call them A, B, C. So the vertices are labeled capital letters only. And one of the angles, I'm going to call it right angle triangle, which measures to 90 degrees. Now, there are 2 things you need to know in Chapter 5, 2 solid things. The first thing you need to know, how can I find the length if I'm given 2 other lengths? And that's called Pythagoras rule. Some people call it Pythagoras theorem, Pythagorean theorem. It simply says what? The tallest side, the longest side that faces the 90 degrees, I'm going to give it a name, C. And that's called the hypotenuse. And one of the sides I can call this A, and I can call this B. These A and B must be shorter than the hypotenuse. All right? What does the rule says? The square of A added, or the sum to the square of B should give me the square of C. C always must be in the left-hand side, the tallest side, the hypotenuse. Okay, in other words, if I'm looking for C only, I'm going to take the square root of both sides, which is A squared plus B squared. Don't cancel these. This is not the same as this. This gives me A, true. But when there's a plus or minus inside, it does not cancel out. So remember that thing, all right? Now, why don't we have an example to make life easy for us? Inshallah, we will have questions if needed by using Microsoft Teams. We are having a right angle triangle. The hypotenuse has a length of 13 centimeters and one of the sides called 12 centimeters length, and let's call this length X. So if I want to apply the rule, which of those 3 sides is called hypotenuse? The 13, because it's facing the 90 degrees. All right? So we will say 13 squared equals 12 squared plus X squared. And if you simplify the 13, use your calculator, 169, 144 plus X squared. If I'm looking for X squared, bring the 144 over here. It's going to be what? 169 minus 144 equals X squared. And X squared equals what? We hold the calculator and we subtract 169, all right, minus 144. Oops, 25. If the length square 25, what do I do to solve this? I take the square root of both sides. So x equals 5. I know you're going to say plus and minus 5, but lengths are only positive. And if the dimension is in centimeters, so the final answer gotta be in centimeter. Okay? Why don't we have another example for you? You do it alone. Okay, doctor. There's an example in your notes. It's a very nice example. And it's in chapter 5. And it's question number, it's about the ladder that is sliding down. This question is simply, I'm looking at my own, it's called, let me make it up for my own before we go to that one. Let's look at this ladder. We have a wall and the floor. And you always know walls are 90 degrees. All right? Now, I am having a ladder who's, let's say, 41 centimeters long. All right? And the foot of the ladder, this is the foot, this is the head, is how much far away from the wall? Let's say it's 9 centimeters. Okay? How would you calculate the highest point or the head of the ladder from the floor? So let's call this H, the height, the vertical height. How about we name these sides? We call this C, if you remember. We call this B, and we call this A. So I'll give you like 2 minutes, think about it, and try to solve it on your own. I'm waiting for you. My advice, put the rule. Plug in anything that's related to the rule. What is C? It's a 41 squared. I decide this is A. Well, I'm going to call it H squared. I decided this is called what? The B. What is 9 squared? If you expand them, 41 squared and bring the 9 squared equals H squared. Go to your calculator. Tell me what's the answer. Exactly 1600. So when you square root both sides, the height is 40 centimeters long. Okay then? This is simply applied when the triangle is 90 degrees. If it's obtuse or acute, no. Okay though. Now, let's move to the second part of this chapter. Anybody? Okay. What did you notice in this question? There were no angles, only sides. I give you 2, you find the third. I give you any 2, you find the third one. But how about if I give you a side and an angle? If I give you a side and an angle, then I must be able to use the 6 trigonometric ratios. These are called the basic ones, and these are called the reciprocal ones. We are having here 6 trigonometric ratios. We can shorten trigonometric by trig. So we say we have here 3 basic trig ratios, and there's another 3 reciprocal ratios that can be used in further math. Let's discuss these things. I'm sure you took in this in grade 8 or grade 9 in high school. But anyway, the sine of an angle, we take the first three letters, and it's the opposite over the hypotenuse, b over c. The cosine of an angle, which is the first three letters cos, so how do you say it? Cosine of an angle theta. It's the adjacent, which is this one. Why adjacent? Because this angle is in my concern. If this angle is in my concern, this is called opposite. Therefore, this is called hypotenuse. Why? Well, remember, facing the 90 degrees. Therefore, the third side must be called the adjacent. Remember the way you think. If you label the sides wrong, the question is wrong. And the third trigonometric ratios is called the tangent of an angle theta. Which angle? I've chosen this. So this must be opposite over adjacent. Opposite over adjacent, b over a. If you reverse each one of those, you'll get the cosecant, 1 over sine, and the secant is 1 over cosine, and the cotangent is 1 over tangent. These are 6 basic trig ratios. It's very worth knowing how to use. Let's take an example. Good? So, the only way you master everything by taking examples and solve them. Why don't I look at example from your lecture notes, chapter 5. I am looking at, if you wish to open your notes, I'm looking at example number, let's start with a 3. Example number 3 of your lecture notes. And that's, which page is it? It's on page 9. So chapter 3, I'm looking at chapter 5, example 3, page 9. This question simply says we have a right angle triangle. Okay. The hypotenuse is 17. And this side is 8. And the third side has a length of 15. This angle is labeled as theta, and this angle is labeled as alpha. Okay? Now what is the question looking for? He wants to find the 6 trigonometric ratios, okay, in fraction form. So part A, we want the 6 trig ratios. He didn't explicitly say for which angle, but if I choose the angle theta, then theta, this is called opposite. This is called hypotenuse. Therefore, this is called the adjacent. So if I want to find the 6 trigonometry for the theta, that's the opposite. Okay? So sine theta, if you look over there, it's the opposite over the hypotenuse. This is in fraction form. Don't give me decimals. If I'm looking for the cosine theta, it's the 15 over the 17. If I'm looking for the tangent of an angle theta, it's the opposite over 15. And if I'm looking for the cosecant of the angle theta, then it's reversing this 17 over 8. If I'm looking for the secant of an angle, then it's the reciprocal of 17 over 15. And at the end of it, if I'm looking for the cotangent of theta, you take the sine, the tangent, and reverse it 15 over 8. That's if I want the angle theta. But how about if I was looking at the alpha? Then the 15 is called the opposite. Not anymore adjacent. But this is always the hypotenuse. Why always? It's facing the 90 degrees. Therefore, this must be what? The adjacent. Now you tell me, what is sine alpha? Opposite over hypotenuse. Opposite over hypotenuse. Aha! 15 over 17. What is the cosine of alpha? Cosine? Adjacent over hypotenuse. Oh, that one. 8 over 17. And what is tangent of alpha? It's the opposite over the adjacent. Oh, the opposite to this is that. So 15 over 8. Please don't put this in decimals. And you can find the rest easily. Just reverse each one of those. This was simply question number, example number 3. Why don't we take another example while you look at it carefully? I'm looking at your lecture notes. Okay, I'm going to look at example 7. And example 7 is on page 10. Okay, I'll clean that. So what I did in example 3, I've shown you how to find the trig ratios. But now, how can I use them? Let's look at this example. We're having 3 sides, a triangle, which is a right angle triangle. This is called EFG. EFG, where the angle F is the right angle. The length of the sides are 8.71 and 2.31 or 2.30. They are the same dimension, so there's no need to put them. If this is an inch, it's an inch. If this is kilometers, it's in kilometers, but you will not have different units. Okay? Now, what does the question want? He wants us to find the size of E and G. So we need to find the measure of angle E and angle G. Let's start with anyone you wish. Suppose I want to choose G. This is my angle in concern. Look, this is called angle in concern. The one I am interested. So by default, automatically, what is this side called? The one which is facing it. Okay, opposite. And the tallest, longest side, what is it called? Therefore, what is that called? Oh, I don't need it. He's not asking me to find the length of GB. He's not asking to find the length of FG. So don't write adjacent. No need for it. So if I'm looking for G, the angle G, if I want to find the size of it, I'm given the opposite, I'm given the hypotenuse. Yalla, let's go to the shop. Choose. Which of these sides has opposite and hypotenuse? Look at the basic ones. Opposite, hypotenuse, hypotenuse. Oh, that one. So let me choose sine, which is what? The opposite over the hypotenuse. What is the angle called? G. So if I'm looking for the answer of G, simply I need to find or to have the opposite, which is 2.3. And I have the hypotenuse. If I'm looking to find for G, Then I have to go to my calculator and find the inverse of 2.30 over 8.71. Let's go to the calculator. All right? Are we ready? Two buttons I have to press. I have to go up to the left, called shift. Then I have to put sign. It will look like this. What do you want to put inside? I want to put inside this one, 2.30 divided by 8.71. Don't forget to close the bracket. All right? And the answer given to you, 15.3. Let's round it to the nearest one decimal place. By the way, this answer is in degrees. How can I change into radians? Into radians. That's a good idea. There's a button on the top called mode. Okay, if you all see it, I'm going to press shift mode. So if you press shift plus mode, oops, you're having 8 selections. 1, 2, 3, 4. What does 4 say? 4 says press, and if you press it, you get radians. Let's try it. Number 4. Okay? And the answer is 0.267 radian. So the measure of angle G can be in degrees or can be in radians. Now, technically I'm done. Why? If I'm looking for E, I have 2 options. The easiest option to realize that angles in a triangle add up to how much? They add up to 180. So if you notice, angle F plus angle G plus angle E, they add up to 180 degrees. I have F, I've got G, and I need E. You know from chapter 1 how we solve linear equations, or how can we solve simple equations? Take those two, add them up, and this one here minus those. So E equals 180 minus 90 minus 15.3. 180 minus 90 minus 15.3, and the answer 74.7. All right? If you want to find the answer in radian, those 3 angles, they add up to pi. That's in radian. Because 1 pi is 180. I can go to calculator, I can show it to you in this way. What's F? F, it's 90, half pi, so pi over 2. What's G? We just found it, 0.267. So in order to find E, we will have to go to the same arrangement. This minus that. All right? So to find E, pi minus pi over 2 minus 0.267. Let's try it. Pi minus pi over 2 minus 0.267. And the answer, E, is roughly 1.304 radian. So, in this question, you are asked to find an angle while I'm giving you 2 sides. Look at it carefully, and let me find another example for you. So again, I have to figure out which trig ratios I have to use. If I don't figure out which one of those, I cannot solve the question. Where is the key? Name the sides. But where is the real key? Make sure you know which angle you're looking for. I'm looking for G. I could start the whole question by looking for E. It's the same process. All right? Now, let's look to a real life question. A question that comes with something real, because all of these were drawn for you. Triangle, triangle, triangle. How about if we look at question number 8 in your lecture note? Look it up. Ready? Go to question 8. Example 8, which I believe is on page 11. He's asking for 4 things. Let's go for it. Let's see how it goes. What is the question about? We have a vertical tower. Very close from Kuwait Tower. The 3 towers, all right? The height of this tower is 328 meters. All right? And a point B is so far from the point S. How far is it? It says 3 kilometers. 3 kilometers. Okay, let's consider a man standing here. His name is Bond, James Bond, and he's how far away from the tower, from the foot of the tower? 3 kilometers. Probably he's having a camera, I don't know. And what does the question say? The height of this tower is 328 meters, and the first he's looking for, what is the height of the tower? I know it seems to you very silly, but the height of the tower is the vertical distance. This is called height. All right? And TS is simply 328 meters. Sometimes reading the question and understanding its English is the key to get into anything. If you don't understand English, sometimes we have a problem. Now, what that part A, what part B says? He wants to have the angle elevation. What do you mean by that? Simply, if I am looking from B at D, my eyes, this is called my eyesight. I'm looking up there, okay? This angle goes from the horizontal towards the eyesight. I can call it theta, but it's called angle of elevation. From elevator. You elevate. When you are happy, you go up. So this is called angle of elevation. You elevate up. It's the angle between the horizontal side view and the actual side view. So simply what I have here, I'm having a right angle triangle. This is theta. This is 328. And that's 3 kilometers. I want that angle. Before I start to struggle, before you even choose, name this side, opposite to the angle. This side hypotenuse, I don't need it, I don't write it. What's left? This side. Then that's called the adjacent. Which of these trig ratios, the basic one, connects opposite to adjacent? No good, no good. Oops, opposite over adjacent. So I'm going to use tangent of theta, which is opposite over adjacent. And since the opposite is 328 over 3, Oh my God, I'm applying the rule perfect. I'm perfect, man. Oh my God, there's something little trick. This is kilometers, this is meters. Are these units correct? Are they compatible? No. Either I keep this in kilometers and convert, I'll convert that one into this. We all know 1 kilometer is 1,000 meters. And I'm having 3 kilometers. How much is that? Cross multiply. So it's the answer 3,000. Aha. So I have to write this as 3,000 meters. This is 3,000 meters. And the meter cancel out. So trigonometric ratios are unitless. How are you going to be unitless if they are different units? It can't be. So you have to make sure one of them is matching the other. Once you know that, they cancel out. Now there is no unit in here. Now I can solve the question. To find theta, I'm going to use the usual thing, the inverse tangent of 328 over 3,000. Well, let's go to the calculator. How much time? Shift. Are you ready? Shift. Tan. 328 divided by 3,000. Oh my God, I got the answer 0.1089. You can't have an angle like that. Oh, I'm wrong. I supposed to convert the calculator into degrees. So rule number 1, you forgot to put your calculator back to degrees. So go again now. Delete everything. Shift mode. 1, 2, 3, 4, 5. Press 3. Okay, now my calculator is ready to give me anything in degrees. Let's do it then. Again, shift tangent. 328 divided by 3,000. Now I'm happy because theta 6.23955. How about if we say 6.24 degrees? Think about it. This is so big, 3 kilometers. Think about this. This is just about quarter a kilometer. So the angle is so small. So I am looking at the tower from the horizontal. I'm looking this way. Oh, now I can see the top of the tower. It's an angle 6.24. All right, guys, ladies, gentlemen. So make sure first, units are the same. We will not give you tricky questions, but this happens to be a ready question, homemade question. All right? Make sure you label. So first of all, know the angle in concern. If you don't know, the question cannot be done. Number 2, label the sides. Where's my opposite? Where's my adjacent? Where's my hypotenuse? Number 3, choose the trigonometric ratio. You don't choose the right one, you will not get anywhere. And make sure you are using the right mode, which is 3. Mode, shift, mode 3. That will give you degrees. Simple, straightforward things. Label your right angle, opposite, adjacent, hypotenuse. But make sure you have the angle known, angle in concern. Then choose the trig ratio. Then just substitute. All right? Let's look at number C. Actually, he asked us to label. In part B, he asked us to label the angle of elevation. We labeled it and we named it theta. Part C, see how nice, we already did it. He's asking us to find the angle. Wow, we're so lucky. And in part D, he wants us to find TB. You can name it TB like this if you wish. You can name it anything else you want. As far as not being, you can call it X if you wish. Why don't I clean everything I wrote and I leave this answer here, 6.24? What do you think? How do you think I could have done that? I'm looking for TB. This is the length of the eye side from your eye to the top of the towel. I'm looking for, find the length or the distance between T and B. Some people say, I can use Pythagoras. Yes, you can. Some people say, well, since this is called hypotenuse, I can go opposite of the hypotenuse. I can use sine. You're right. Some people say, I can use cosine. 3 over that, I can find theta. Some people say, why don't I use tangent? You can use all. You have 4 ways to go. Why don't we choose anything? So if I choose cosine theta or cosine B, what's cosine? It's the adjacent over the hypotenuse. It's the adjacent over the hypotenuse. What is the angle, B or theta? It's actually 6.24 degrees. What is the adjacent? Oh, the adjacent is 3 or 3,000. Remember that one? And therefore, the hypotenuse called X. How can I solve that? Simple algebraic equation. If you put that one, everybody can see it. Remember chapter 1, question 2? Cross multiply. So X times cosine 6.24 equals 3,000. What do I do next? Divide both sides by cosine 6.24 and here cosine 6.24. Don't forget degrees. Bye-bye. This will cancel out. Let's go to the calculator. Before we touch it again, this must be in degrees, so double check. Shift mode 3. I'm happy. 3,000 divided by, don't press shift, just cos, direct, 6.24. And don't forget look when you press, don't just do like this. You have to close the bracket, equal. Oh, your answer is 3,017.9 meters. So if this is 3,000 meter here, and this is 328, this distance, so big, is about 3,017.9. I think in this chapter, we covered the most important 2 aspects, the key. That's where you can stand. Whenever you have a right angle triangle, make sure, keep in mind all the time, Pythagoras, trig ratios. Pythagoras, trig ratios. If you don't keep this in mind, let's say it's a bit hard later on, if you are an engineer or a surveyor, if you were asked to find the area of this triangle. Remember, we'll talk about area of triangle next time. When we talk about chapter 6. When we talk about chapter 6, we'll put more examples. What I want from you now, there are examples in your lecture notes. Please do question number 9 and 8 and 10. Next time, do questions 9, 8 and 10 of chapter 5. If you do them, inshallah within 2 days, I'll post the model answer for you in details. And we can discuss things. If you still have no problem, you understand, we can discuss on our Microsoft team. Have a nice day. Goodbye. and see you next time.